It is me, John Park, and I've got an echo, so let me take care of that. Hey, thanks for coming to join us today for John Park's workshop. I'm John Park, this is my workshop, and I'm here for Adafruit Industries to build some stuff and chat with you all and take a tour through an interesting topic of making music with solenoids. That's our topic today, as you can see right there, solenoid music. That's what we're going to be up to. We've got the thumbs up from the chat over in Discord. C. Grover says that we have a good audio level. And it's hot today, so I have a couple of fans going. One of them is just for my camera. I put a 120 millimeter case fan from an old PC of mine, pointed it right at the back of the camera. This is the one that's been overheating sometimes. I found out there's a firmware update that may also help with some overheating management stuff. We'll see if that helps. And I also opened up the battery door. This is another tip. I found one of those YouTube videos of 10 tips for how to keep your Sony Alpha 6300 from overheating when you're shooting video. So then I got another fan that's blowing air into the workshop. I don't want to run the AC because that's super loud, and especially because we're going to be doing some cool sound-based stuff today. Now, you may remember a little while ago, one of my thrift store finds was this pressure zone microphone, this PZM mic that I got, which we think was made by, was it not by Shure? Gosh, now I can't remember. A real mic manufacturer made this for Realistic, or at least gave them the patent or the rights to do it. So anyway, this thing, I switched this to balanced and put a battery in it, and it works pretty well now that it's balanced. It's not making too much ground noise. Crown, thank you, C. Grover. It was a Crown microphone. I got it for $8, I think it was, or $5, something like that. So anyway, I'm going to use that. I'm going to mix that in at some points to see if that helps us with picking up some of our little solenoid sounds that we're going to make. Aw, Yannick, thanks. Said we got a bunch of fans in the channel too. Woo! By the way, since we're going to be doing some interesting sound stuff today, I wore my Dope what does it say? Klangforschung? I think that means sound research or noise research, something like that. In honor of doing some musique concrète. I don't speak French, but I think that's the right word for what we're doing today. Okay, so first thing I want to jump into then, since it looks like we're doing good. Caesar Gaming, is it okay for me to be here? You're the admin on the Arduino Discord. Sure thing, Caesar Gaming. Welcome. Caesar Gaming is over in the YouTube. You can hang out in the YouTube for sure. We definitely have people in the YouTube chats and the Discord chats. I've got some delicious iced coffee. You know, I like cold brew, and I actually built a big solenoid valve-based dripper for doing overnight cold brew at a regulated drip rate with a big thing of ice water. You may have seen that project before. Well, this was dead simple, and I've never tried it this way, but it was delicious, which is, I think, I'm getting this right. What I did is, I think, similar to a Japanese ice brew method where I'm using a pour-over filter and pour-over apparatus over ice. And every drip goes in and cools off immediately, which they say keeps the acid low. This is very low acid, so delicious. Thank you, Yannick. Yeah, so for people who are wondering, musique concrète, that is a term I'm guessing it means something like music from the real world, from the concrete world. And I barely remember this from some of my music history back in college, but John Cage, I think, did some. There are some better examples of people who did musique concrète, which is making music with the sounds of everyday objects. Could be traffic noises, could be banging on a trash can. So we're going to do some related project here today. All right, so next thing is our coupon code. So for today and today only, if you want to get 10% off in the Adafruit store on everything that you could possibly want, with the exception of gift certificates, software, and subscriptions, then use this coupon code, tap, tap, tap. That will get you 10% off. Sprink Design says anything with klang in it is good for you. That's excellent. I hope I'm not shouting today, but I'm trying to be heard over the fan, at least in my own head. This is a pretty directional little mic, I think. It's probably not too bad. Okay, so yes, 10% off in the Adafruit store. All kinds of great stuff that you can get, including some related things to what we're going to be doing today. But you know, if you go and check things out, because there are some awesome collector's pins that are never going to be available again. And I just picked up this little beauty right here, this little Adabot. Cool little pin right there. And you can get 10% off of that. Go get, ooh, Stuff with Kirby says, anyone else get their Adabox today? Did you get yours? That's exciting. Yeah, let me pull this down. So 10% off, tap, tap, tap. I'll bring that back up at the end of the show, by the way. The Adaboxes have started shipping. Yes. So tomorrow night at 9 p.m. Eastern Standard Time, I'm going to be doing the unboxing of Adabox 8. If you look right there, there's a little peek. If you didn't want to know what color Adabox 8 is, I am sorry, because now you know. It is this awesome green. Kinger North got theirs yesterday. Yeah, so I believe the shipping has begun. Some people will get them probably over the next week or so, depending on where they're being shipped to and from. But this is it, man. This is Adabox 8 time. So tune in tomorrow night. That is Friday, July 13th at 9 p.m. Eastern Standard Time, and you can watch the unboxing. If you got your Adabox and you want to follow along, play along, that's awesome. If you didn't yet, but you're dying to see what's in it, tune in. If you hate spoilers, don't watch. Don't do that. I just noticed I have a piece of printer filament that's wiggling back and forth back here. I built a spool up there. Did you guys ever see this? Let me see if I can tilt this up far enough. Yeah. There's a spool holder for 3mm right over my Ultimaker there. It's just a dowel. Nothing too fancy, like Joel Telling there, 3D printing nerd, built some crazy shelves recently. Okay, so let's now move on to a quick little product of the week. Fix my camera again. Product of the week is something we're going to be using today, and that is this delightful little push-pull solenoid. So this is a 5-volt solenoid. A lot of the time when you go out and look for solenoids out there, you're going to find 12-volt. There's a lot of 12-volt solenoids out there. And those are great, but it can be difficult to find the 5-volt ones, which are easier to power from boards. You're gonna need transistors. You don't want to run these straight off of your typical microcontroller board because they suck down a lot of current, about this one a little more than an amp when it's energized. But 5-volt is the one you want, and we've got these great little mini push-pull solenoids, which means that the electromagnet pulls the shaft in and pushes it back out. It also has a spring to help with that return. So these little guys, it's product ID 2776. They are inexpensive. They are $4.95. And for our project today, I needed to have 4 of them, so I'm glad they're not too expensive. But those little solenoids, one reason I really like them and the way we're going to use them today is because you can run them off of this guy, off of your Cricut board. Oh, look. I have one right here. It's wired up to stuff. And you can see in the corner, right there, oh, I'm going to touch the wrong side because I'm looking in the mirrored image. We have this section of drives. And so this section of drives on the Cricut board can drive up to 4 electromagnets or solenoids. I don't know what all else you can run off of them. I suppose if you got anything that just wants to get hit with 5 volts, you can do that too. It's not going to be a refined control like the motor controller, so I I suppose you could just run motors full speed or not. Let me know if there's anyone in the chat who has experimented with plugging in motors over there in the drive section. I have not. In fact, have I plugged anything other than solenoids? I don't think I have. So, yeah, Yannick mentions in the chat that these mini solenoids could be used like a door or a treasure chest lock. Yes, for sure. In fact, I built a project on the Learn Guide using a solenoid as a little treasure chest. It's up there in the corner, actually. I'm going to run out of time if I keep getting distracted, but let me show you this one. I think this one's maybe a 12-volt solenoid and a bunch of batteries. Do I have it running right now? No. Oh, it's empty? Is it empty? I gutted this one. Sorry, I lied. Yeah. I stole that solenoid. I can't remember where that one went. But yeah, you can use solenoids for little latches. There's at least 2 or 3 projects on the Learn Guide, in Adafruit Learn Guide, that will show you how to build different types of drawer latches and treasure chests where the unlock mechanism is pulled with the solenoid. The thing about solenoids is that if you don't get a latching type, you don't want to try to energize them for long periods of time. So it's a easy mistake to make, thinking, oh, you know what, I'm going to have this thing pushed out for a half hour, and then when someone presses a button, we can open it. You want to have it so that they are not energized most of the time, and then for a short period, you'll energize them, usually to flip a little latch so that you can open something. And we'll be talking about that actually as we get into this project. The duty cycle of a solenoid tends to, rule of thumb I use is somewhere around a quarter, about 25% of the time. It should be on, 75% of the time off, so that you don't burn it out. They can get hot and they can get angry. So, all right, well, guess what? We are about to get into it because it is time for the Make Code Minute. Ta-da! All right, Make Code Minute today. I'm going to take that graphic off of there and let's jump into it. So here we've got our Make Code up, and I'm going to go find that window. Where'd you go? There you are. All right, is that one the one that's up? It is. Okay, so let me simplify this real quick. I'm just going to set that stuff over there. You can read ahead if you like. But right here in Make Code, with the Cricut extension enabled, so this is one thing that if you go to Make Code, you won't see the Cricut extension right away. You'll need to hit Advanced and then head down to Extensions and click on the Cricut extension. And that will load that package into Make Code. And now you'll have this category that you can select from. So let's take a look at how you actually energize a solenoid to make it tap. So if I click on Cricut and scroll down to drives, we have Cricut analog write drive and a number to 0. And that's all we're going to need. So we don't need to worry about the frequency. So what I'll do is I'm going to grab this and let me try to see where I'm placing that there. Right on my face. Hello. How about there? Is that a little better? Right on my chin. Let me move it up into the side. That's not too much better. You know what I'm going to do, though? I'm going to zoom way the heck in, because why not? This will actually be a small... Yeah, it's legible now, mostly. Okay, so... By the way, since I like to peel off these Make Code minutes, which are always way longer than a minute, but I like to peel them off and put them online as a separate little video so that people can find those if they're not watching the whole show. And I forgot to kind of make this nice and concise. Let's start it right here. So for the Make Code Minute today, we're going to look at running a solenoid using the Cricut. So what I've done is selected from the Cricut category this Cricut analog write drive 1 to 0. And what this is going to do is it's going to tell our solenoid drive, and we have the 4 drives on the Cricut, right here, 1, 2, 3, and 4, to send anywhere from 0 to 1023 as the value. So this is the full 5 volts at the full current that it can supply. So now what I'm going to do is add a little bit of a delay. So I'm going to grab the pause loop from loops, and this is going to, let's delay this for 100 milliseconds. Actually, this default is good. Then I will duplicate the Cricket Analog Write Drive 1 and send it down to 0. So what this means is we're going to get this little tenth of a second tick of the solenoid energizing and flicking the little shaft out. And now I'll add another delay, and this can be the sort of pause between clicks. So let's make this, how about half a second? Okay, so now what I'm going to do is download, and I'm going to save that over to the board. So I've got this Circuit Playground Express on the Cricket right here, and I don't know if this is plugged into one, because I've got 3 wires in there. Let's see, that looks like that one's on 3. Let me unplug that. I'll show you in a second how I built these, but I've got these little extenders that are helpful but confusing me at the moment. So that one there goes to 1. Watch this Make Code Minute later, and you'll see this section edited out probably, so we can jump ahead too. Okay, so I'm downloading the code, and now I've got the solenoid plugged into drive 1. I'll upload that to the board. And now you can see my solenoid is ticking. Let me close this window that's graying things out here. All right, so with that code right there, you'll see the solenoid gets energized and clicks just for a tenth of a second and then returns every half of a second. And that is how you drive a solenoid using Make Code on Cricket with Circuit Playground Express. Now, let's try to make things a little more interesting here. Let me pop this right over here. And I'm actually going to just get rid of the code that I had in there. By the way, this is something that I did not realize until recently. When you're deleting blocks, let's just add a random block, and it can be a collection of blocks, let's say. In Make Code, you can just drag them over to the left, and you'll see that the categories section turns into a trash can, and you can let go. I tried it randomly one day because that's how you do it in Scratch, and I suddenly remembered. Oh man, TrueTech code Dopefer would have been super dope. I wish I had thought of that. But it is not. It is tap, tap, tap. That's right, yeah, if you hear the tapping noise, it's because it's working. So, okay, so that was me throwing out stuff on Moss. So let me zoom out a little here. And what you can see is, I'm going to pause that clicking solenoid for a minute. Now what I have in my forever loop is just a series of pretty much the same thing. I've got my first solenoid, but you can see there's this drop down where you can pick second, third, and fourth as well. So this is one discrete section of the first solenoid ticking, and then a half second later, the second solenoid, third, and fourth. So what we're going to do as we get into the project is start out with that. Then we might get a little fancier and add some speed controls and things like that. But this is kind of a nice, basic setup for being able to test up to 4 solenoids and tapping them on different objects. So what I'm going to do is head over to, you know what I'll do? Let me re-upload that code to the Circuit Playground Express so I can make sure that every solenoid is working. Drag that on. Okay, and now I know that's working because this now clicks every 2 seconds. So it clicks and then it's waiting for the other 3 solenoids and then back to him. Right. So now what I'm going to do is unplug from this power here. And I don't need the USB cable connected for now either, because all the power that runs the Circuit Playground Express comes over the Cricket. So let's head over to the workbench, and we will pop up the overhead cam. Yeah, that'll work. All right, let me head over there. take the less noisy path, and I'm going to bring my coffee with me, my iced coffee. When I was making coffee earlier, my daughter was like, how can you possibly be making a hot drink? And I said, I'm not. I'm making iced coffee. I don't know what the temperature is, but it's probably around 96, 98, something like that. Okay, so let's zoom this little beauty in here just a little bit. And so you can see here actually I'll go to this camera. This one's even better for this. Let's go to that view there. And I'll focus on that one. So this is the little 5-volt push-pull solenoid, and you can see it's got this magnetic coil here wrapped up in some protective tape, and that is the shaft with its little spring return that travels when the electromagnet gets energized. It has this little JST connector, which is on the face of it not that useful with the Cricket, because the Cricket has screw terminals. And the screw terminals are nice and versatile. And you'll see here in a second, I'm going to unscrew all the wires that are in there, get us back to the starting point. Okay, so you can see here, this is our drive section. And what it has is get that out of that view. It has a single terminal for the 5 volts, which is energized, and then we're controlling these 4 ground pins. So with multiple solenoids, you can plug one wire of each solenoid all into this 5 volt, and then one wire from each solenoid, respectively, into these 4 pins for the drive's grounds, and that's what gets triggered when we are asking a solenoid to go ahead and drive. So you can, if you want, cut this little connector off and strip the wire ends and plug that directly in. But what I decided to do was use some of these JST wire connectors that we have. Here's one. So these are meant to be battery extensions. It's a JST PH. That's the particular size of that JST connector. So JST PH battery connector extension, and what I've done is taken these, and you can see there's a female side, which will accept the solenoid, and then there's a male end, and what we're going to do is get rid of about that much by cutting this and then stripping it. So that I might use for something else someday, so I'm going to set that over here, and then I'll split the 2 wires away from each other and strip a little bit off of there. Oh, and while I'm over here, let me pull up the chat, because always helpful to know what's going on. I'm trying to bring up YouTube and it wants me to watch something else. No thanks, let's watch this. Gesundheit. Okay, good. So what I'll do now is just strip off a little bit of these 2 wires. I'll strip the insulation. Okay, so now if we just want to drive the one solenoid, what I can do is twist these up a little so they don't get frayed. And then I will plug in a wire into the 5 volt. Now these solenoids are not polarized, I don't believe, so you can place either wire in either hole. It'll do the same thing. Oh, so you want to make sure that, sometimes I solder these two just to kind of tin them so that we don't get a little frayed strand of wire making a short. There we go, that looks good. Okay, so now what we can do is plug in, oh, That one came out. Let's try that again. Good. So now what I'm going to do is plug in the solenoid into the other end of this battery extender. So JST connectors match up nicely. And let's power up the Cricut and Circuit Playground. So there you can see we've got that same every 2 seconds this one will go off. And now what I want to do is add more solenoids. So let's, here's another one, and I have wires for these. So what we'll do now is actually turn this off. We're going to make a sort of nice, neat little wiring harness for these solenoids where we can solder together 4 of the wires so that they all go in nicely into that one 5-volt. And then the other ends will go into their respective ground ports. So you can see I've got 3 of them kind of twisted together. I think 2 of them are actually soldered. So peel this in equal length. Okay, so these wires are actually thin enough that we can twist them together, solder them, and they'll still fit into that screw terminal pretty well. So I will grab a helping hand. That looks pretty reasonable. Move that so you can see it a little better. And, oh, I gotta turn on my soldering iron. Move that a little closer. So the project that we're going to build today, we're going to end up using these 4 solenoids to tap on things musically and rhythmically. And when I was doing a little bit of research last night to see ways that people had arranged these sorts of, particularly how they've connected things up so that you can tap on a glass, you can tap on a piece of metal, I ran across a bunch of different great creative solutions, and one was a Kickstarter. I don't know if it's out or not, but it was called the Automat by Dada Machines, I believe, and it's really cool. What we're making is, in a lot of ways, what that product is. It's just the product is a much more refined version, really targeted at musicians. It's a little board that has 12 outputs for solenoids, and it has MIDI input and MIDI output, and I think maybe a USB, so that you can control it from Ableton Live or a MIDI keyboard. And I thought, wow, that thing is really cool. And essentially, we're making our own miniature version of that with the Cricut and Circuit Playground Express. But if you want to look into that and need a dedicated machine for what we're going to build today, that one looks pretty cool. I just don't know if it's out yet. So we'll go ahead and solder these up. And that's all that takes. I think that's all the soldering we're going to do, too. There's a chance that I'll want to tin those ground wires, but let's see. So now, this little bundle here, let's see how that plays with our drive terminal. Pretty good. It's just long, so I'm going to trim this so that we don't have as much exposed because we don't want, or you know what, even better, I think I'll put a little bit of heat shrink tubing on it. Kind of neaten it up and just give me the amount exposed that we need. Heat shrink always makes things better. That's nice. Yeah, I like that. Let me just grab a lighter. I feel like moving this. Is this one working? Yes. Okay. Neat. No, let me see if I need to refocus that. Good? Yep. All right, so let's screw that one in. Attempt to screw without bumping this camera. Ooh, you ever have that moment where you go, I haven't checked the chat in a while. I hope they're not yelling at me that I've like lost a camera. Ooh, so far the cameras all seem to still be working. That's worthy of a URL. Yeah, I will look at that when I'm back at the computer in a minute, Matambale. I will find that and post that. Super cool. Cool. Good. Yes. Do I make iced coffee normally? Brent, you know what? I am on and again and off again with making iced coffee. I actually found that Trader Joe's has a pretty good cold brew, so I often, out of laziness, get that. But when I do, I usually make it either in, I have a Hario little tabletop setup, and then that one's easy and small to get out and use. The big giant one that I built, it was an article I did for Make Magazine. That one is put away in boxes right now because it took up, kind of intentionally, it took up like this much space, and it made a huge amount of coffee at a time. All right, so now what I'm going to do, I think let's try to tin these guys just to make everything a little neater. And I don't think they'll need the heat shrink, but let's get out our helping hand and just make those neat. Let me put this under the camera properly. Sorry about that. I'll try to refocus. There we go. So let's bring the iron over here. And like I say, this is mostly because we don't want to short anything. If we try to throw two of the solenoids at the same time from one port, there's a chance that we'll sort of brown out and cause the Cricut to reboot, and we don't want that. So I want to do this neatly. This is me being slightly paranoid. You can certainly get away without doing any soldering at all and just twist your wires and put them in. It's actually one of the strengths of the Cricut is that you don't need to be too fussy about this stuff. You can actually get it working pretty easily with very minimal tools. But I'll be slightly exacting about this and go ahead and tin up these wires. I've used screw terminals a lot over the years, and I still don't know what the optimal solution is for having enough give that the springy little terminal wants to bite down into it but not pop out. All right, so now what I want to do is actually, for a sanity check, I think I'm going to try to mark these as 1, 2, 3, and 4 as I go. So let's zoom this up and out a little bit. Sorry for a second. As I adjust that camera. Boop. Okay, so I've got, and you know what? I need more light. I'm actually going to crank the door open a little more. Where's that? Okay, this is going to get loud for a second. Hold on. Also, the cameras will shake. Oh, other way. There we go. Okay, so what I'm going to do is just mark these 1, 2, 3, and 4, and I think I'll just try to do it. You could get sexy with it and use some colored heat shrink with it. I'm just going to get a fine tip marker and indicate on here. This one is going to be 1. And then I will screw that one down into drive 1. Oh, look, there's the one I forgot to tin, and it immediately wanted to fray apart. Okay, quick tinning. I have found that the header pins that we have on the TT motors work great in the screw terminals. Normally they're made for wire more than a pin, but those ones are just the right size. They work really well. Okay, so this one I've marked as 1, so that's going to go into drive. Let me unscrew that a bit more. Okay, and now what I'll do too is trim this down to just the right length to go in into that terminal without leaving too much exposed. You don't want to be biting down into the insulation either. Okay, that one's in great. Let's move on to the one we'll label as 2. Number 2. And that'll probably rub off with handling. So ideally, something like some heat shrink tubing if you're using this thing a lot. Okay, that one's a good length to stay in there, so that goes into drive 2. And this labeling is just to keep you from driving yourself crazy later trying to figure out which solenoid should be going. Okay, so this will be number 3. Okay, it's also a pretty good length. So if you haven't noticed, because I've been using it so much lately, I am really pleased with the Cricut. It makes this type of project so straightforward by having all of the different types of drivers for motors and servos and neopixels and these electromagnets all on one board. You don't have to pile on a lot of shields and things or wings to make your project. It's all in one spot. All right, and this is number 4. Okay, so now let's take a look at, let's go to this camera here. So now let's take a look at a mounting issue. So now we've got these 4 on here. Actually, let's plug in the other solenoids just so we can do a test of them all clicking. And I'm going to hide a couple of them. You'll hear them, but I'm not going to talk too specifically about them because I don't want to reveal the very cool, fun solution I think I have for our mounting issue. Hint, it has to do with Legos. All right, so let's plug that in there. And set these right here. I'll turn on, let's go back to this camera. I'll turn on the Cricut. Okay, so you should hear 4 of them clicking now, and I'm gonna try to turn up this PZM mic for a second and see. I think it might pick up a lot of fan noise, unfortunately, but let me I'll put on headphones and see. All right. Yeah, tell me if that gets a weird echo with me talking. Yeah, you're right, John Schaffstall. I'm only showing 2 of them right now. It's because I'm hiding the other 2 from the very cool and big reveal. Yeah, you hear 4 of them. So the issue with this, let me turn this off for a second, is that how do you want to mount these to something so that we can tap with this little end of the solenoid and make it adjustable. So you could clamp it down in a vise. I was using some of these helping hands and just kind of connecting to the wire, but these things jiggle a lot. And so what I decided was to sacrifice a couple of flat Lego plates and glue these down to a sort of consistent little Lego piece, so then I can create like a big mounting plate and connect my solenoids and maybe even connect the objects that I want to strike. So I figure Lego is a pretty good consistent type of system. It's its strength in life, right? It's a consistent system for hooking these up. So what I've done is simply hot glued a couple of dabs of hot glue on the back of the case of the solenoid, and then set them onto the two little sacrificial Lego plates. Make sure that's in focus there. Okay, so I am sorry, Lego purists. I did just glue something to Lego. You know, it's hot glue. You could definitely get it off using some isopropyl alcohol if you really needed those back. But now I've got these two flat plates connected pretty nicely to my solenoid, and then those two flat plates are Legoed on, no glue, just Legoed onto this 4x4 third height plate, and then I can mount that to things. So you can see the other solenoids you were hearing before that I wasn't showing you are already prepared like that. And now I've just got one more to do. And this is definitely, again, I have to give credit to the Dada Machines developer, because one of the things that his kit comes with is some Lego-based adapters for his solenoid. So I saw that and I said, this is brilliant. I'm going to make a DIY version of that for this because it's an excellent system, I think. So I have one more of these that I've prepared, and I'm going to hot glue the last solenoid onto there. Got to be quick because the hot glue cools very quickly against the metal since it acts as a big heat sink. You know, I've been making cardboard stuff for the last few months, and cardboard does not dissipate the heat, so it takes forever for that glue to cure, but it's pretty fast on this metal. Okay, so now you can see I've got my little set of 4 solenoids. Let me neaten this up. Untwist them. There we go. How fun is that? All right, let's right these guys for a second. We'll just turn them on and watch them dance around. I'm going to check that audio again. I didn't see in the chat if anyone had any problem hearing that. You knew hot glue would be part of it. I know. I've become such a fan. All right. Yeah, that fan noise is not too bad with that, so I'm going to leave that PZM on. I've got a little reverb on there too, so that you can hear them more than just a high tinny ticking. So let's turn that off, and now let's take a look at making some sounds, making some music with these. So just in this configuration, we've got, let me go to this view. Just in this configuration, we've got our little plate that I made, like a base plate. And you'll never believe this, but I found a Lego that is pretty exactly cricket sized. I just double stick foam taped it onto here, but I'd like to come up with a better way, maybe using screws or standoffs or something like that. But there's this piece that's an octagon. I swiped it from a Lego Star Wars Sarlacc pit. This is why it is in the tan sand color. But I thought that was pretty cool, so now I can mount my cricket just with some extra regular bricks right there. So that'll mount pretty nicely in place there. And then I can take my solenoids, and we'll go number 1. Set this over here, like so, just on the edge. Let's take number 2. Set it right there. Let's just play with these two for a second. So let's start off with a glass. So here's a glass jar, like a little mason jar. I'll turn this on. I'll move this microphone. Sorry, it's going to make some noise. All right, that's pretty good. So I was hoping to do some pitching of this sound with water. And what I found is you can get about something like a whole tone. So listen to that pitch, and then I'm going to add water. And it definitely dampens it. Bum, it was bim, now it's bum. So that's kind of cool. You could definitely experiment with that. I think that if you used a crystal glass, you'd have a lot more resonance and a lot more success. I did take one of our wedding champagne flutes. I wanted to test this. I haven't tested this until now. This is the first time, so let's hope it doesn't just shatter. Let's see. Woo! Yeah! Get it just right. Let me take one of these and hold it. Yeah, so I think you might want to suspend these so that they can ring and not get dampened by someone holding them or the table. But then I wanted to think beyond the glasses, because they didn't make a ton of noise, is I've got some of these mason jars or bell jars, canning jars, and I put the lid on this one. Let me move this right about here. I've got some water in this one, and I'm going to have it hit the lid. And what I want to do is set down some like little rubber or something to hold this in place, or some putty. Get it to hit it. There we go. So let's see. I had some of these sticky. Keeping with the Lego theme, I have some of this Lego tape. So I'm just going to set a piece of it here so this will stay put. It's nice if it can give a little bit. There we go, get a different tone. Something else I wanted to experiment with, and this is again something I saw in the Data Machines video, is a little striker that moves a tray that's holding objects. So I put some googly eyes inside of, this is a mason jar ring and a piece of paper. If we set this over here, we might get a better pickup on the mic. Okay. Let's see. Do I have anything else that was kind of interesting to hit? Oh, yeah. You know what really makes a lot of nice noises? This plastic cup. This is actually the ones that I had used to do my eyeballs demo from PT's eyeball method. So these, if we set one of these here and whack it with a solenoid, we get a pretty nice sound out of this. Yeah, ping. You can see it just shot it away. So again, I want to set down, I think, a little bit of this rubber tape so that it doesn't go so far. I might have to put some weight in it. here. Okay, so at this point, we're getting tired of this same pattern, however. So what I'd like to do is jump back over into make code and do something a little bit more interesting. So let me turn this volume down here for a second. Let's jump back here and over here to our make code. And yeah, that was risky, Brent, using the champagne flute. Need to strike the glass above the water level. Oh, thanks, Seagrover. Let's just try that real quick. Let me turn that mic back on. That makes sense, because I'm dampening it, aren't I? All right, let's turn you on. All right. Oh, yeah. Nice. Okay, that's smart. That makes it better than down here. Yeah, it's much tinnier when it's down below. Smart. Okay, so now there's a couple things we can do in make code. One of them is just the tempo. But the other thing we can do is add a bit of a pattern to the drumming, kind of like a sequencer. And I'd love to make a sort of full-blown step sequencer for this. It would be super fun. Let's go over to make code. Let's switch out for this. So here was one idea I had. I'm going to switch my main camera to this view here, and we'll zoom out just a little bit. This was based on an idea that Phil Terone, Mr. Lady Ada, had last night when we were chatting about this project. We talked about maybe doing glasses filled with dyed water so that you could have the colors correspond to blocks. Since I'm doing these different types of objects, I wanted to do an experiment with, instead of showing make code just over my face, showing make code over the objects. So what I've done now is broken up the solenoid tapping, which, if you'll remember, is essentially sending it to full power, pausing in that energized state for 1/10 of a second, and then returning. So I've turned those into functions. So for solenoid 1, which is actually over here, reverse these. So there's solenoid 2, there's solenoid 1, there's the solenoid 4, solenoid 3 is down here, not doing much of anything. So I thought this was kind of a fun way to look at what's going on visually in the real world and inside of make code. So now that I'm using these functions, what I could do is change out my forever loop. Instead of tapping individually, I could just call on those functions. So I'm going to just pull this off for a second and kind of hide it over here. So let's add in function calls and see how that works. So here's call function solenoid 1, and then we'll do a little bit of a pause. We'll make this a little faster this time. How about now this duty cycle? Yeah, that'll still work. Okay. So now I can duplicate, move on to solenoid. We could change our pattern up too. We could go to 4, pause, 2, and 3. Should work. And let me turn this back on and then plug in. I've got my USB cable plugged into the wrong thing. Easy mistake to make. I plugged it into the Cricket. I don't want to do that. That is the Seesaw flashing port. There we go. Now it's in the right place. All right, let's save this. Tap pattern functions, I'll call this. And I'm just going to copy that over to board. Oh, you can hear I got a funny pattern because I forgot one of the pauses here, so this one follows very quickly after it. Turn this up. Oh yeah, you can hear that. Yeah, John Schaffstall mentioned in the chat you probably don't want to run these concurrently, and I sort of am at this point because I forgot this pause here. But yes, inside of each function I do the release, so they should all be released before the next one does anything. Okay, so let me pause this. And this is a nice thing I've noticed when you're doing the development is you just hit if you've got your Circuit Playground Express plugged into USB, you can just press the reset button and it goes into bootloader mode, which just effectively pauses it, and you're probably iterating over in make code and getting ready to drop in new code. So let's do this. I'm going to pull these out. We'll kind of ignore our functions for a minute. And let me bring in this. So this is the code that I was playing around with the most before we started the show today. So what I'm doing, let me put my face back in here for a second and move this. Okay, so what I'm doing first is in this onStart loop, I'm going to zoom in. I'm setting all of the neopixels to yellow, or orange actually, and then I'm setting up two variables. I have the rest variable, so this is how long is the rest between each note or each beat. And I'm setting this to 400 milliseconds. And then I'm setting up the duty cycle to be 1/4 of whatever the rest is. So this means I don't have to go and hand change things a lot, and I don't have to worry about if I make the beat faster, will I accidentally overheat the solenoid. So this is a nice little setup here, and then all the calls throughout the rest of the code are based on those variables. So with every loop of this forever loop, I'm going to move forward a frame of this animation that just lets me see visually something ticking forward. And then, unlike the functions I had before, I'm just explicitly doing my little send the solenoid out, pause for whatever that duty cycle amount of time is, and then retract it. Then I'm resting the beat amount. And then I decided to more quickly tap number 2 and number 4. So we'll get a beat, and then we'll get 3 beats, and then we'll get a beat on 3, and then we'll get 3 beats on number 4. So this is not variable time, this is just whatever I typed in. Let's try that out, and then we can get even fancier in a second. So I'm saving that file. This is something you're not seeing on the broadcast, by the way. When I save the file, I'm dragging it over to the Cplay boot. John, I'm sorry, yes, it's 7/8 time. For some reason, like, these weird time signatures have been cropping up a lot lately. Partly it's because my son's a guitar player, and we were listening to some Led Zeppelin that was in crazy, like 4/4 on the drums and 7/8 on the guitar or something like that. Okay, so this is kind of cool, but now what I'd like to do is be able to adjust that timing using the buttons. So, sorry if we'll go a little bit long. Let me pause this. But this will be the last thing I promise, last make code thing. So now what I'm going to do, I don't think I have it already in here. Oh, I do, look. Ah, okay, good. Like a cooking show, I did make these and keep them, so I don't have to make them from scratch. That's a good thing. Let me zoom in on these two. So similar to what I did last week using the buttons to increment things, but actually I'm doing a smarter method. Jacqueline at Make Code showed me an example of something, and instead of doing a math node to say rest equals rest plus a number, there's this nice little block that's available in variables called change variable by a number. And you can go up and down with positive and negative, and then you could also throw other math nodes in there if you wanted. But what's going to happen here is every time I press button A, the rest amount is going to add 20. And so that's going to slow down the beat. And every time I press B down, the rest is going to subtract 20. And so that's going to increase the beat, if that makes sense. And then inside the next block, what I'm doing is changing the duty cycle to match. So it's a quarter of whatever rest just became. And that happens in both cases. So that is actually running on here. And I can go ahead and play that. So I can slow it down. And this will be loud and weird, but I'm going to set this one solenoid right on the mic. Let me flip that upside down so it's metal. And now I can speed it up. And that is our impromptu concert. So I hope you enjoyed that. I think these little solenoids are a ton of fun to play around with. Obviously, I'm just sort of scratching the surface. I had some ideas of using some plucked strings, bring in a ukulele maybe, hit some wrenches. I have a bunch of different box end wrenches there that would probably sound pretty good. And then there's the notion of how do you mic these things, and do you want to feed them through effects processors to add echoes and delays and things like that. I've got a little bit of a echo effect going on, or reverb. Yeah, there's a plate reverb on my mixer that I was putting that PZM mic through. But I think, yeah, cowbells would be hella tight. Everyone loves cowbells. So in honor of our Klangforschung, that was the sound research for today, using the little 5-volt solenoids on the Cricket with Circuit Playground Express using make code. It makes it really a lot of fun, pretty easy. Oh yeah, transducers would be great too, especially picking up some of those magnetic fields. I'll probably do a little additional thing with this sometime using my field kit. I have a little box from Coma Electronics. I'll just show it real quick. This, we don't have time to plug it in and use it. I was thinking of doing so, but we ran over. This little box is used for exactly this type of musique concrète, and it's got different contact mics and transducers and things that you can plug into this little mixer here, and then there's other LFOs and CV-controlled radio and some bits of effects on there that you can use it for. So just adding a loop of effects and processing and filters and things to this stuff and miking it either with contact mics or regular microphones, you could come up with some really interesting sounds, I think, just tapping on stuff that exists in your world. So that I will leave us one parting shot, which is 10% off in the store today if you're interested in picking up some solenoids to play around with, or a Cricket. I don't know if the Cricket's in stock right now, but the solenoids look like they are. You can also run these off of the Feather Cricket using a Feather M0, M4. Some of the previous Feathers, not as shiny and new, would all work just fine. But if you want to program inside of MakeCode, make sure it's a Feather M0 Express or Feather M4 Express. Yannick asked how you drive the solenoid without the Cricket. So you could use I think we have a motor Feather wing that would drive solenoids, but I'm not certain actually. Otherwise, you can look on, actually I think in the Learn Guides you'll find an example of running them using a transistor circuit like a MOSFET in order to
send through, not driving it from the board itself, but send through current from another power supply. Someone says use a 2N222. Yeah, it looks like we have a solenoid driver guide. If you look in the Discord, you'll see a link to that. So the solenoids, I've got to throw a link in there right now. Here you go. These are solenoids. There's a link for you in Discord. There's a link for you over in the YouTube. If I could find the, I've lost, there's the, hi, I've just found the Facebook chat. There, I threw a link in for that too. Oh, and that's weird because now I've got the echo of me. Go away, echo of me. Okay, so that 10% off, tap, tap, tap. Use that on anything that you'll want to get in the Adafruit store today, except for subscriptions, gift certificates, and software. And so, with that, I will thank you so much for stopping by for John Park's workshop today. It's been a real fun time building this kooky thing with you today. And I hope you come by tomorrow to check out the unboxing of Adabox 8. There it is right there. Adabox 8, that one right there. I'm going to open that up and we'll take a look at what's inside. It's at 9 o'clock Eastern time on all of the YouTube and other Adafruit channels where you might see video. 8 p.m. Eastern Standard Time. David Boyd on tomorrow, July 13th, Friday, July 13th, not February. You can come by and check that out. So with that, I will play us out with some groovy solenoid music. Thank you so much. I'm John Park, and this has been John Park's workshop for Adafruit.